So, good morning, everybody, to yet another exciting session of Spatial Talks. Today, we have the topic is emerging tech, virtual reality, and automation. And we all know that acquiring geospatial data has witnessed immense transformation with new and innovative technologies coming into picture. And this has made the availability of data very accessible. Now, this accessibility has given rise to new applications and new solutions and new products. And historically, these were queried on the 2D desktop and very, uh, 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 rudimentary computer environment, but with technologies like AI and ML, deep learning, uh, IoT, we have seen a very drastic transformation from 2D to 3D, and we have now digital twin, which is coming up, which is another area of exploration and understanding of how geospatial data can be applicable into different domains. So in this session, we have the virtual reality mesh model and automation, where we have the finest resolution in matter of weeks. We have it, and this is possible because of the capabilities of the data acquisition on an ongoing basis, and also of a 360-degree nature. And this combined power of geospatial information together with virtual reality, augmented reality, AI, deep learning, we are now going to witness a new set of products and solutions. So today in our Spatial Talks webinar, we will be talking about these emerging technologies and how they are transforming the landscape in the geospatial domain. So today we have 4 speakers on our forum, Dr. Mila Cueva from the University of Twente, Mr. Naresh Soni, Tech Summit Foundation CEO, and Dr. Pravakar Behra. He's from the Polosoft Technologies Private Limited, and Ms. Shikha Miglani. She's the co-founder of Sarthi. So we start with our first presenter, Dr. Mila Cueva. She is an associate professor at University of Twente International Institute of Geoinformation Science and Earth Observation, ITC, the Netherlands. She holds a PhD and MSc degree from University of Architecture, Civil Engineering and Geodesy in Sofia. Her career includes 10 years of working as photogrammetry department of GIS at Sofia, producing cadastral and topographical maps. And she has also worked with an organization called MapX for 3 years and leaded 3 big projects of EU that was related to geodesy, cadastral, and photogrammetric activities. And her main areas of expertise is digital twin, 3D modeling, image data acquisition, and processing technologies such as satellite, aerial, and UAVs, and automatic feature extraction for cadastral mapping and urban planning, among others. More recently, her research is focusing on implementation of innovative geospatial and machine learning methods based on remotely sensed data from Earth observation in 3D urban modeling and cadastral applications. So over to Dr. Miller.
Thank you very much. Thank you very much for inviting me, for presenting me, and for being all among all of you. Now I will share for my presentation, and please give me a sign if you see it, everything correctly. Yes, you can see the slides in slide mode now. Can you just give me a sign?
Yes. Yes.
Good. Okay. As I mentioned, thank you very much for inviting me. It's a pleasure for me to be among you. Today, I will talk about digital twin applications. I will share with you some of our recent work on this topic. But before starting, I would like to give you a bit of overview. What are digital twins and what do we understand from digital twins? There is no clear definition in the literature. I refer on this slide to the definition which was done by the UK or Gemini Principles, which refers to a digital replica of our physical world, including buildings, roads, and everything which is in our environment. What basically distinguishes the digital twins from the normal models or city models is the relationship with the physical environment. So in general, digital twin term is relatively new, but behind it, there are many concepts that are not so new. We have been working on 3D modeling, 3D city modeling, or building modeling in the past 20 years. So they're not so new. What can we do with digital twins? We can build the historical overview of a city, for example, its current representation, but also we can do some future simulations, some future predictions. And the main idea behind digital twins is to have more synchronized data, data which is derived in an automatic way, and kind of a dynamic data integration between the users and the producers. And also you can see on the slide, we also aim in shareable data, more accessible data from the audience, from the users. Another question that we can answer before I give you some examples is why do we need such representations in the form of digital twins? One answer can be that we can answer many societal questions which are strongly related with geospatial information, for example. We can think of pandemics, urbanization, which is nowadays in many cities. People are really working and living in very urban areas, and the land is limited. So naturally, our cities are growing in the third dimension. So visualization for urban planning, for climate change or disaster management are pretty essential in cities. And 3D or digital twin representations can be of great help to solve these societal issues. Now with this slide, I want to kind of tell you how do we proceed when we want to create digital twins. How do we create them? Since I'm working in a department which is quite related with Earth observation and geospatial data. This is faculty of ITC, maybe you have heard in the University of Twente. So to create digital twins, our approach is a little bit more data driven. As you can see on the slide, we start from the aim of representing our real world into a digital twin format. And we usually start with what are the available sensors and platforms that we can use to acquire some remotely sensed data. So we can use satellites or airborne images or UAVs, unmanned aerial vehicles. We use quite a lot of UAVs nowadays. After that, we go into a processes of for example, combining these images with LiDAR data, can be point cloud data obtained by laser scanning, which is airborne or terrestrial or mobile based. And collecting all this geo information, we are usually trying to process in an automated way or extract automatically some objects, for example, with machine learning or deep learning algorithms, so that we speed up the data creation of data collection and data creation for the digital twins. Very often we combine our work with additional sources of information like maps that exist in the organizations or building information, modeling information, which are kind of domain of the civil engineers, where they can provide us with more intelligent and more detailed models. And usually we use cloud computing or 3D database to store this information. So this is our regular working cycle. And of course, depending on the different purpose of our projects, we adapt to the methods and the processes that we are using. But I just wanted to share with you how do we approach the problem of creating digital twins. And now I would like to share with you some examples from our work. So with this example on this slide, we work together with the Dutch cadastre. And since they have very regularly updated information from aerial images, as you can see on the slide, and LiDAR point cloud data, we tried to combine these two point cloud data sources. So the second one are point clouds which are produced via dense image matching technique. So two point cloud data sources were integrated into one. And the aim of this research was for solar potential estimation. You can see here some preliminary results on this research. We have modeled 38 buildings, which were generated with different roof types. And after creating the models, we had to assess what is the difference of using the 3D models as an input information for solar potential analysis. And compared this method with the one that is currently used by the cadastre, which is just to use a DSM, this digital surface model. And you can see here some results. So basically, we converted the 3D models into rasters with two different resolutions. You can see 0.2 meters and 0.5 meter resolutions. And the main parameters that are assessed are the roof slope, the orientation, and the effect of the shadow cast. You can see that the outputs are raster layers, where each pixel has some solar potential given with kilowatts per square meters. And you can see that the results that we obtained with using directly 3D models are slightly better than the current process of cadastre, which is only using DSM as an input information. Another example here is related with automation, because in the previous research, the most time-consuming part was detecting the correct geometries of the building shapes. For example, detecting the roofs out of and outlines of the buildings. And then we used in this research deep learning approaches to automatically detect the outlines and inner lines of the buildings. This is quite a challenging task. So currently we have even more students working on these topics. Every year we are upgrading and further developing the methods for this task, because it's pretty hard. But in this particular research, we used remote sensing data, which is openly available with 25 centimeter resolution, and combining it with DSM, digital surface model. All this data is available in the national database here in Netherlands. We also combined it with cadastral information, where we have footprints of the buildings. From this research in the Netherlands, I want to bring you to another research where we were using 3D, and it was in China. There were 4 students that were interested in dynamics of property prices in the city of Xi'an. This is because in China there are quite high buildings, and the prices are not equally distributed. Let's say if you're living on the first floor or the 20th floor, you might end up with the same price of an apartment. But a lot of factors basically should be considered, which should influence the price formation for such kind of properties. So we kind of dived into a topic of 3D property valuation. These students in the beginning, they have done the research by doing a lot of interviews from buyers, from group discussions with experts, and they tried to determine the indicators that influence the third dimension. And you can see here in the slide what were the basic indicators of importance that they have, let's say, found. And they visualized all this in 3D and analyzed the dynamics of the prices in the 3D through the years. So we did kind of even 4D, as you can see here, 3 years were explored, 4D property valuation. The same research kind of got continued from a terrestrial point of view. Here we looked at the different angle, for example, how the street visual features are influencing the property values. Again, we used deep learning algorithm, and if you can see here, we used quite a huge number of images. We used semantic segmentation, and we did quite some statistical analysis. What are the factors that are influencing from a street view point of view? Another nice example for digital twins that we have been working is this work of a student which was in the city of Rotterdam. And you can see that we have incorporated overground and underground in the same model. This was kind of to bring the two worlds to work together, the architects and the geologists, which have different data sources, different way of working. We wanted to bring their outputs into one model. So you can see the pipelines underground. We have done quite some analysis on the potential exposure for example, heat, for floods. This is the one for floods. So it was quite an interesting project with Rotterdam municipality. On this example, you can also see a research which was on digital twins and basically incorporating the information of a flood, of water, and also how would this influence in case of diseases. So this was a research in Brazil, and we worked on a slum area in Brazil where this is quite overpopulated, and we analyzed how this would how the spread of diseases can be when there are some floods. You can see here a small video. We simulated here when there is a raising of the water, how much it can influence the population. And it was quite a nice research. On every of these slides in my presentation, you can see the resources of papers. So you can click on the links and see more of the research. Currently, we have also quite a nice research with a colleague from India, Shubham. I think he's also in the audience, and via him I was invited to this seminar, and he's also doing a very interesting research on Delhi, combining the historical maps in the past from the city of Delhi and trying to incorporate different methods with a variety of geospatial information like raster and GIS-based information, and he's planning to recreate the historical view of Delhi and to do some web-based simulations of how the city has grown through the years. So you can expect from us more examples in the future to give you also on your city, Delhi, in future. With this, I want to conclude my talk on digital twins with some, let's say, sentences in conclusion. So the main message in general of my talk was that the creation of digital twins can be very promising solution for many societal challenges, and photogrammetry and remote sensing methods are quite powerful, and combining them with some innovative geospatial methods and information, and also using AI and deep learning techniques, we can extract a lot of automatically a lot of information based on these powerful resources, and we can apply them in a different applications. So for every application, the approach can be different, and of course, we can combine the technologies in a different way, and with all this, we can try to achieve some sustainable development goals, which, for example, can address some global environmental and societal challenges. Of course, there are still many challenges and problems that are remaining and that can be solved. As you can see on the slide, I just mentioned some of them, like scalability, transferability. Usually, as scientists, we are trying our algorithms and our methods on small areas, and then we are trying to scale it or to develop methods that can be transferred from one case scenario to another. So these are the works that we are currently busy with. And of course, a lot of data integration issues that you can see in the slide. Many different sensors can be used on different platforms, and other geospatial information which is coming with different formats. And this is causing quite some challenges for our domain to integrate them and to show them in public. So with this, I want to conclude this talk. Thank you again for giving me the honor to speak. And I hope there will be questions that we can have afterwards to discuss. Thank you very much.
Thank you, Dr. Miller, for such an insightful presentation on digital twins. And going forward, digital twins are really going to be the game changers, because we can relate to it as it is the virtual representation of our physical world. And because it's kind of an as-built representation of our environment, it would be easy to comprehend it. It will also be easy to make others understand through these digital twins. Thank you so much for sparing the time and be with us. It was really a very nice presentation. We'll have the question and answer sessions post the speakers. In their presentation. So next on our panel is Mr. Naresh Soni. He is the CEO of Texman Foundation. Mr. Soni holds a master's degree from TU Delft, the Netherlands, in geomatics, and bachelor's degree in mining engineering from Indian Institute of Technology, Kharagpur. Before joining Texman, he has been working on various remote sensing and GIS applications in mining and other domains. So over to you, Mr. Soni.
Thank you very much. Am I audible?
Yes.
Yeah, and my screen is visible also?
Yes, screen is visible, but I think there is some. Yeah. Now it's yeah.
Okay, thank you very much, Swati ma'am, Yogita ma'am. Thank you very much for inviting me. Thank you very much for this opportunity to talk about this advanced topics in GIS and remote sensing. So my topic will be data management for Earth observation. So what Dr. Mila just mentioned in the final conclusion, the problems which are there, I will just elaborate a little bit on top of that. About me, I'm Naresh. I'm 2009 graduate in mining engineering from IIT Kharagpur. I have a master's degree from Delft University in GIS and remote sensing geomatics. I worked a lot on radar interferometry. I have done some work in oil and gas industry also. Since 2015, I have worked on a couple of my own startups. I was building a 3D mapping system, hardware and analytics engine for 3D mapping. Currently, I'm CEO of Techsmin Foundation, and I will talk a little bit about this in the next slide. Uh, so before we talk about technology, I would like our audiences to know about a program called NMICPS. So a couple of years ago, Department of Science and Technology, Government of India created a deep tech fund of about 3,600 crores. That's approximately $500 million. The program is called NMICPS, National Mission on Interdisciplinary Cyber Physical Systems. There's a website. I have shared the link also. Maybe you guys would like to go on that link also. And how the fund is being dispersed is via 25 technology innovation hubs (TIH) under the umbrella of major IITs and reputed academic institutions. Like IIT. There's a little bit of background noise. Yeah, so IITs, IISc Bangalore, BITS Pilani. And these technology innovation hubs are Section 8 companies. Section 8 company means that these are not for profit organizations. So they are into technology development, commercialization of technology, but whatever profits these companies make, they put the money back into the ecosystem. And there's a big part in international collaboration also. So one such TIH is Technology Innovation in Exploration and Mining, Techsmin Foundation. Techsmin Foundation is under the umbrella of IIT ISM Dhanbad, and we are primarily working on mining and exploration industry. Earth observation, I believe everybody knows, but just for the sake of it, data coming from satellite imagery, coming from drones, aerial data from helicopters, aeroplanes, and the ground data from terrestrial lidars and mobile lidars. So that's how we collect the data from the Earth. When we create a virtual reality, a 3D model from drones, we take images from various angles, we put it on a software, and we create a 3D model. Similarly, when we want to create a 3D model, we take images of some archaeological site, we create a 3D model, a digital copy of the asset. What Dr. Mila just said, create a digital twin. What's happening very interestingly in last 3-4 years, because photogrammetry is an old technology, it's been there for a long time. But in last 3-4 years, the drones are changing at a very fast pace. 3 years ago, the image size resolution used to be like 12 megapixels, and suddenly we are looking at 100 megapixel drones. And when we get into that, the pixel size has gone from 12 megapixels to 100 megapixels. We are looking at 8 times increase in the size of the data. So that's a big problem. What I think right now that is existing is that huge amounts of data is coming out of the GIS and Earth observation industry. Like there's a flood of drones, not just in India, but all over the world. Practically, drone is becoming a commodity. Satellite constellations are coming up in last 2 years. I think 2 or 3 radar constellations have come up. So terabytes of data is even a small number. Now the data is getting into petabytes. The teams are distributed. There are at 10 different centers, 10 teams wants to access and work on the same data. So a desktop node is not sufficient anymore. That's not going to work. And further, the type of data sets, point clouds are there, satellite imagery is there, then hyperspectral imagery is there, then 3D maps are there, then GIS layers on top of it. Way too many kinds of data are coming, and putting that data under a single platform. So sensor fusion can happen. It has its own challenges in terms of data management. So the future, what I think the future is moving, and in fact, it's already a present. So many companies are already working on this. It's coming out of academic research now that the phones, tablets, iPads, whatever you have in your hand is just a visualization layer. You just view the data there. Other than that, the complete analytics, storage, archiving, everything will be happening on the cloud, where you will be able to handle petabytes of data, fuse data from various sensors, and compute that data in a reasonable amount of time. For example, in the Netherlands, there's the AHN data, complete point cloud of the Netherlands is available. And you can take a small sample set, you can take some 50 houses, or you can take up 2 or 3, 4, 5 square kilometers of area. The research can be done, POC can be done. But when you want to scale that to a complete city or a complete country, that's when we are looking at huge amount of data, and processing of that data could potentially take months. And that's where everything has to move to the cloud. So the ideal way of working would be that multiple drone operators are working, hundreds of 500 drones are working, let's say, collecting the data. There's a web app where you can do the data sanitization, verification, the data is of good quality, upload the data on the cloud, and the cloud does its magic. All the analytics engine integration is built into the cloud. Petabytes of storage can be managed, and the output could be 3D maps or 3D models or whatever you want that can come out of it. So right now, we all know that how the photogrammetry processing works. We collect the data, we put on a desktop machine, then we have a software on the computer, we do click, 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 a number of processing, and then some data comes out of it. Then we move that data to some QGIS or ArcGIS software where we do analytics, or we use some open source software. That slowly has to change because the user is not a GIS expert. We cannot expect that people will truly understand how to use QGIS. I personally know so many people who know a little bit about maps, but as soon as they go to QGIS, ArcGIS, they feel a little bit lost. So that automation has to play a big role, that the user just knows what he or she wants. They go to the platform, they just put their requirements and get the outputs in a matter of hours only. To give you an example of data size, where this data management problem is coming up. So Swamitwa scheme is the government of India scheme. Survey of India is mapping all the villages of India using drones. To put some numbers, and a drone imagery per square kilometer is about 7 gigabytes, which is being used, a standard drone, not even high resolution drone. And each team is expected to scan about 5 square kilometers in a day. So we are looking at about 35 GB of data coming from one team. And under one company, about 20 teams are working. So we are looking at about 700 to 800 gigabytes of raw data coming every day. That has to be uploaded in the night and has to be processed the same day, because the next day, another 700 to 800 gigabytes of data is coming. So under Swamitwa scheme alone, it is expected that about 50 to 100 petabytes of data is going to be generated. That's where the current problem statement is. And these kind of problem statement comes from countries like India, actually, because it's a huge country. And as soon as, we look at a large scale project, suddenly the data size is not in terabytes anymore. Just to add a little bit of a small point in the end. So the 3D maps are the future of navigation. It's a natural evolution. From paper maps, we went to 2D maps. Yeah, everybody is using Google Maps, but that is moving towards 3D maps for navigation, for autonomous cars, for a variety of applications. What Dr. Mela also mentioned, that they are working a lot on 3D. So the 3D models they are making, they will be used by a number of applications, and I believe that 3D navigation is going to be there in next 2 to 3 years, and the amount of data that is going to be managed for that is just extraordinary. That's all from my side, and they will have a discussion after the presentation. Thank you very much. Thank you very much, everybody.
Thank you, Naresh, for giving a beautiful insight at how we are going to handle the data. We are talking about technologies and how technologies are transforming, but the major challenge is of how we manage the data, which is going to be coming in such a huge number, and how I just had an chance to view the drones data from few of the projects under Swamitwa only. And the automation, because of automation, there are a lot of errors in that drone data. So this is going to be a real challenge for us, that how we are going to eventually, it was like hybrid model where we have to work. Right now it is that, but how we can take it forward and how we can build automation to have a less error in drone data. That is where we should look forward to.
Yeah, it's
and
coming
thank
actually.
You. Yeah, this is coming.
Yeah.
So thank you so much for the presentation. presentation. And next on our panel is Mr. Pravakar Behera. He is head of GIS in Polosoft Technologies Private Limited. Having a master's in geography, he has more than 20 plus years of experience in GIS and remote sensing from different geospatial and IT industries like RMSI, CAMSEX India, Kobe India Limited, Rolta India Limited, and currently as a head of GIS in Polosoft Technologies Private Limited. He has roles and responsibilities such as project management. He has taken up the roles and responsibilities like project management, GIS expert, and consultant. And his core area of expertise are geospatial project management, technical support, consultancy service for different geospatial projects, presentation of implementation process and guidelines for GIS and remote sensing projects to the different industries as per the requirement of the clients and the users. So over to you, Mr. Behra.
You are on mute, Mr. Behra.
Kindly unmute.
You are on mute. Can you unmute yourself?
Is it audible right now?
Okay,
Yes,
so good afternoon, everybody, and thank you for giving me this great opportunity to share my knowledge on some GIS and remote sensing part. And I think my presentation is visible right now. Is it visible?
No, not yet. You have to share it from the bottom.
Okay.
There's a share button with an arrow.
Oh, just a minute. Okay. So is it right now?
No, sir. We are not able to see.
So I think, is it visible right now? No.
No, Mr. Behra, we are not able to see your presentation.
Sorry, I'm sorry. If you click on that up arrow, you should get a box.
Yeah.
You see that box on the right with the up arrow, click on
Okay.
that. It'll suggest you a screen, pick the first screen, and you should be good.
Okay. That's great.
You got it? Yeah.
Yeah, this is okay. So
Yeah.
I think this is visual.
Yeah.
Yeah,
Can you
this
put
is
it on
visible.
slide mode, please?
Yeah. Slide mode. Okay. So this is me actually, Mr. Soni and ma'am. He has already explained about the advanced of the 3D modeling and everything. Okay, so it is my simple topic, and basically my topic is on cartography, GIS, geographical information system, and the procedure to how to collect the data of the GIS. And my keyword of this presentation is the map makes the life smarter, faster, and easier. And my topic is this geographical information system and augmented reality. Basically, I will talk on this. So, go for the geographical information system, I need to describe the cartography first, and everybody know. I think this is the map making process, and by using some design principles, cartography design principles, that is legibility, visuality, contrast, and everything. And there are so many other design principles also available. And for map it is a symbolic representation of the place and object phenomena, which conveys the geographic information useful in understanding the topography, weather, and cultures, depending upon the map type of the maps. So this is all about the map and what is the map and how the process to collect the map. And this is the first world map prepared by Greek academic Anaximander in 16 BC, and he was the father of cartography. And this is one of the cartographic map, and which indicates this is the painted maps. This is the painted maps, and just handmade cartographic map, and it these are the real world location of the cartographic maps. It is the one of the example, and this is also one of the project actually we have done some before some month, and it is some university. It is a university project, and we have done this project. It's a cartographic project actually. There are so many features. You can see that there are so many features available, like the settlement areas and settlement areas, water features, relief features, and forest areas also. And the client need was only to extract the historical settlement automatically. So we have used some software to automatic extract the settlement area as per the color, red color. So it is a, and then after we have some attribute, we have give some attribute for that settlement area. So this is one of the example of ours, and this is also another example. This is the parcel mapping. It is one of the means cartographic, beautiful cartographic map with different colors and buildings and roads also. And we have done these projects. So type of, if we talk about the type of cartographic map, there are so many types, and basically topographic map and land parcel map, cadastral map, and navigation charts, and so many other means thematic maps and geological maps are also in cartographic maps. And this is the classes of map based on the maps are actually basically classified as per the scale basis, and the scale, it is everybody knows that the scale is the ratio between the map distance and the corresponding distance of the ground. And there are three type of scale: a large scale, medium scale, and a small scale. And the scale between 1:1000 to 10,000, that is a large scale, and medium scale is 20,000 to 1 lakh, and small scale it is more than 10 lakhs up to 25 lakhs. So the scale factor is commonly used for every map, mapping by every industry as per their purpose. And based on purpose, there are two type of maps generally, and the first one is the general purpose map, which this map focus on the locations of to show a variety of physical and cultural features, and such as landforms, roads, drainage, and railways, and built-up areas, forest, everything. So this is the common purpose map. Yeah, please.
So can we get into that augmented reality part of your presentation? Because I think most of the audience would be aware of this.
Yeah. So okay. So this is yeah. So from this remote sensing part, everyone know the basic of the remote sensing and how the remote sensing data are collected. And this is we have done some Gulf Coast mapping project on remote sensing imagery data. This is one of the example, and this the aerial photographs, how we are collecting the procedure. And already Sony has Mr. Sony, he has already explained about this. And this is another data collection method through mobile vehicles, the LiDAR data collection, LiDAR data, and 3D data collection method. And this is the UAP data collection method, already we have discussed earlier. And this UV data also used for the lighter classification, 3D mapping, and generation of DEM, DTM, and DSM also, and contour generation and 3D part. So these are the advantages of the drones. There are so many advantages of the drones. It's a very powerful instrument to collect the high quality data and large scale aerial photographs for the geospatial users. And probably all the maximum of the corporate industry and the public industry are using the drone to collect the remote sensing data of the ground. And drone is the cost effective and easily deployable instruments. And yeah, through drone imagery, we can produce the 2D, 3D map, 3D vector maps, DTM, DEM, and contouring also, and modeling of the earth, and also make the 3D map to orthophoto and then 2D mapping also. And these are the application of UAV data, and these are the sectors, and maybe more than these sectors are using the drone and UV data for mapping. And these are the non-spatial, and these are the non-spatial data collection method, that is, and these are the non-spatial data collection method, and the survey types: POI survey, topographic survey, road property survey, and utility survey, consumer survey. There are so many types of surveys through which method we are collecting the non-spatial data for the metadata maintenance and handling. And this is the first instrument, that is GPS. Everybody know the GPS we are using to collect the lat long and altitude of the ground, and total station, auto level and total station. And through auto level and total station, auto level it is manually, and total station is quite automated, and through which we are collecting the lat long and altitude of a point, ground point, and to georeference and the remote sensing imagery as per the reference of the total station GC points. And also we are modeling the data also, modeling. And this is the GPS global position system, and this is another instrument to collect the data. And these are some fundamental of GPS. What is the official name of Napstar? GPS is the official name, and its accuracy, that is 10 to 20 meters. It is accuracy, and we are collecting the lat long and altitude of. And this is the DGPS method. It is just the differential global positioning system. It is more advanced than GPS. Its accuracy is 1 meter to 10 centimeter.
Sir, I would be interrupting again, but can we go to your augmented reality section, because this is all the fundamentals most of the people know in this audience. So we want to look forward to hearing you on the AR part, the augmented reality part.
Okay. Just it is, yeah. Okay, augmented reality, and it is the advanced procedure of data collection, and it is augmented reality is the enhanced version of the real world, real physical feature that is achieved through use of digital visual elements, sounds, and others. And actually, through augmented reality applications, we are means these days different type of all the industry, means utility industry, specifically utility industry, telecom, and water sectors. They are using this instrument or application to find out the underground. Features, metal features like pipelines and network features, and visualize the undergrounds, and display the 3D modelings. And also the augmented reality application, it is also using in 3D modeling, sorry, BIM and CAD also. And we can also, yeah. So this is one of the example. This is the raw map, and on the right side it is the augmented reality, and this is the map area, and this is the building. And through augmented reality application, we can see the connectivity of the drainage systems and the piping, where it is going to the properties and everything. So, and this is one of the local based, location based asset labeling also. This is one of the example. And indoor, and for indoor and outdoor, we can use, we are using the augmented reality applications and Google map view. Google Map, it is having a great facility of AR application, while so we can use this to locate the place and with our surroundings. And this is also another example to find out the underground. You can see that there are so many underground pipes, and we can identify these piping networks and piping conditions, how the condition is for maintenance and everything through augmented reality applications. So it helps and display the feature available beneath of the surface of the earth on the screen, and which can help the user to take more efficient decision making rather than checking back to the blueprint and notes. And augmented reality application, it is very useful to locate and track the underground means what I can say, underground features, utility features, and the metallic features, pipelines, and everything, without digging that particular place and identify what is the condition and whether the maintenance or any thing is required, repairing is required for that. So for the medical purpose point of view, augmented reality X-ray also it is available, because the medical physiotherapy department also, they are using the augmented reality instrument to find out the muscular and skeletal real-time data. So this is one it is another example of augmented reality, that this is the you can see that the left side, it is one of the paper map on the table, and you can also create a 3D model project on the in this on the table. So it is actually uh, this process is to build the project planning, and it is a means building the construction development to build the 3D modelings and identify the issues where and saving the time. It's a time saving process, and also the money, and it helps the user to take the good decision, and no need to means use any technology or a software to model the 3D buildings and everything. So this is one of the process. And this is the second, this is the another example, 3D modeling in FME software, and that is also a very good 3D modeling software. So in this software, there is a augmented reality facilities is there, and you can plan a project. You can create the 3D modeling, means 3D modeling of the buildings and everything. So you can see and plan according to the project. So this is the it's a example of interior decorator, and the left side image is that is a plan of a building, and the second the right side, that is a means it's a 3D modeling of that models, and you can just create this application create the 3D model on a particular table, and you can just see how the model is looking like this and everything. So also the AI is using for DEM data modeling. I mean, it's a digital terrain model, DEM and DEM modeling and of the Earth surface. You can see that on the table, and also we can use this AI to add some other features on digital terrain models. Like water, buildings, and everything, we can add it and we can see it, and it is very clear and useful. So this is my conclusion, and okay, so it was very simple presentation from my side. Thank you very much.
Thank you, sir, for giving us the examples of augmented reality in real life conditions, specifically in navigation and how, like from 2D cartography, the things have evolved to
Yeah.
Ms. Shikha Miglani. She's co-founder Sarthi and an Inc. 5000 data analytics company. She founded Sarthi in 2014 with a vision to build an impactful organization. A small project led to a series of statements of work, and with word of mouth organic growth, Sarthi has become America's fastest growing private company in year 2020. She brings to Sarthi 18 years of industry experience in analytics, technology, and consulting. She enjoyed the entire experience of bringing together data, technology, systematic analysis, and business intelligence, and communicating meaningful patterns for business planning. She brings in a unique blend of technology, analytics, and consulting to her engagement. Her technical skills across systems and platforms and her ability to read data make her a unique and valuable partner. She has been rated as most valuable partners, multiple partners by stakeholders she's worked with, and she has overseen multi-million dollar project engagements for Fortune 50 clients, overseeing a high level and as well as granular details of these projects for successful project execution. She can seamlessly architecture data interfaces and weave insights from this data, creating impactful executive presentation. Her vision for Sarthi is to build a data and analytics company which is driven by business and domain needs in every aspect of project cycle. She is an alumna of Pennsylvania State University, USA, and MNIT Jaipur, India. After completing her undergrad in electronic and communication engineering from Malvi National Institute of Technology, Jaipur, she pursued systematic engineering for some time, and then she bridged her professional experience into analytics. Besides Sarthi, she also founded Girl of Substance to promote gender equality, a cause she deeply believes in. So over to Ms. Shikha.
Yeah, hi everyone. Thanks, Yogita, for the introduction. And we are America's one of the fastest growing company in 2020.
Yeah.
So that's the
Okay,
connection.
just a second. Can I request Mr. Behra to stop sharing his presentation screen? Yeah. Thank you.
I can ask you a question.
Shikha, you
Hi,
can.
Yes, you can ask.
Okay. So a lot of this data is public information out there, right? From the way I was perceiving, the geo data is public. It's available to everyone, right?
Yes, for course resolution, obviously it's available to the public, but very high resolution data, uh, the availability varies from country to region based on the policies of each country. But yeah, free of cost, like data till say 10-meter resolution from satellites and from Earth observation, other Earth observation. But the other like drone data and all that, you need to capture it. So, and even aerial photographs, one needs to capture on the need basis. So I have one question for Dr. Miller. As to we are now talking about the 3D digital twins. How do you see its application emerging in all the areas, and how it is going to transform from the 2D to the 3D? The way we look at the problems, and how the solutions are going to be a game changer from a 2D perspective to a 3D perspective.
Actually, from 2D to 3D, this change has started since long ago. So it's not something that in many countries, of course, there are some digital challenges, but in general, the change to 3D has started. And the idea behind is to speed it up even further more than the architects start not thinking in 2D, but to start directly with their design projects in 3D. So we are trying to let's say, explain the benefits if they directly start from zero directly in 3D. Same for the civil engineers. It is a hard change, like everything. When you're already, in many countries, people are still paper based and are used to paper based. So the switch to paper to digital was pretty much challenging worldwide. And the same way, the switch from 2D to 3D is not an easy one. It also depends a lot on the available technology in the different countries, available open source data, as it was asked by Shika, if I'm pronouncing it correct.
Yeah, that's perfect.
Yeah.
That's perfect.
So it very much depends on the availability of the data sources. So here in Netherlands, for example, we're pretty lucky that there are a lot of open source data. Like also Sony mentioned, there are a LiDAR acquisition every 2 years. So this is quite an expensive way to acquire data. Not in many countries can really afford it. But yeah, we are quite lucky in that respect. There are a lot of aerial images that are also open source available. Like several months ago, the cadastre in Netherlands even opened the very high resolution images, like 8 centimeter resolution. So in the past, they were 25, 30 centimeter, the openly available in the Netherlands. Now are even 8 centimeter, which is giving a very powerful resource of information for researchers to explore new methods and algorithms with this open data. About UAVs, I agree completely with you, Yogita, that it's really much on customer dependent. So it is still not open source, and you have to acquire it. I can add something on the question that you were discussing, that in India nowadays you are acquiring a lot of UAV data, but you mentioned that sometimes there are errors. This is what I heard that you mentioned. I don't know what exact errors you referred to, but we had a lot of projects with UAVs, and we have done a research that I can share later in the chat if you want. There is a paper published on using, we compared 6 UAVs, different UAVs with different flying heights, with different image overlaps and different number of ground control points. And based on this comparison, we tried to derive conclusions that are useful for those that are starting with flight planning. What would be the optimal configuration that they can follow so that the images that have no gaps, for example, and you have let's say satisfactory final results without errors, if you're referring to this error. So it kind of rang the bell when you were talking about that.
Yes. Yeah. So basically the errors were because of the difference in the flying altitude and attitude, and when you do the automated processing, these errors can be reduced when you do the manual processing, when you do the subjective processing. But when you do the automated processing, these errors get inbuilt into that processing, and the end output, the end result, is not so what can I say, forthcoming, and it's not so valuable. And when we have to extract information from those aerial photographs.
Yeah. Okay, so you were referring mainly from the processing point of view.
Yes,
and
from
when
the
I was listening to you, I was thinking that errors can be also avoided also from the data acquisition
points. Yeah.
starting point. Yes.
Yeah. So the errors they creep in processing is because of the acquisition only. So once the acquisition errors are minimized while processing, you'll have less errors, because the combining of images, the mosaicing of the images, all that is dependent on how best we acquire the data.
Yeah. Yeah, thanks for this clarification. I was wondering what were you having in mind, and also having all this big data, as the Sony was saying, it's pretty challenging how to store it, how to manage it, and how to distribute it later, because he knows better than me most probably how this is.
Errors, actually, Dr. Mila, so the biggest source of error, so I have done a lot of photogrammetry processing, and what you just mentioned, all this, different variations, all that we tested. And it depends a lot on the software. So the open source softwares which are available for photogrammetry, they generally don't perform that great because the image matching is not so good. Some problems are there. But the biggest problem that I see in the data collection for the drone industry is that, all of these are a single frequency GPS is there. So inherently the image has 10-meter accuracy. Now for a construction project, for example, I want to build a road or something, I have to have at least 5-centimeter accuracy. So I put a ground control point. Now the ground control points are a bigger issue because establishing a quality ground control point, the surveyor has to understand in depth that how all the sensors and constellations are working. Now most of these people, they think that, okay, buy a sensor, put it somewhere, collect the data, and okay, it's done. But that's not how it works, because the moment we go into the hilly region, then half of the sky is gone. Then our dilution of the DOP is increasing massively, and suddenly there is a 5-meter error in the data. Then what they do is that they do some manual adjustment, try to match with Google Earth, and they do data fudging also. Then the next problem comes, the next set of data is coming, then that is not overlapping anymore. So right now I'm looking at such a problem statement that the drone data was collected on the area where there was no road, and the lidar data was collected from a vehicle where there was an existing road, and there's a difference of 20 meters in that. And
oh my God.
Everybody's blaming each other that, okay, whose data is wrong. And because there was no quality control on the ground control point, because that's sacrosanct, because the most accurate systems are GPS systems, DGPS systems, total stations, and nothing will ever beat that. And there's an understanding gap also, because drone operators are not surveyors. They know how to fly the drone, how to process the data, but they don't understand surveying, and there's suddenly a technology gap. And that's another bigger problem. And one more point, what you mentioned is that when we collect the data, let us say that we collected 2 square kilometers of data today, and 2 square kilometers of data then after 7 days. When you are, even after good quality ground control points and sufficient overlaps also, a meter or couple of meters error is always there. The data is not going to match with each other. How do we match orthophoto? So there are like two ways, One way is that we use AI, machine learning, and computer vision. We find the control points, we merge on top of that. But that's again a crude method, because we don't really know which data was of higher quality. The better would be that if we can do something at bundle adjustment level, where, so when the data size is increasing, the photogrammetry algorithms has to change bottom up. We cannot just, yeah. So that, and I hope that ITC is doing something there. ITC is one of the finest photogrammetry departments in the world. So I hope that some research is going on there, because, SIFT was the sacrosanct algorithm. Everybody was using SIFT for photogrammetry, but now the latest computer vision algorithms are coming. Their image matching is extraordinary. And somebody needs to fuse that with photogrammetry. I think your digital twin projects will see unprecedented details.
Yeah, I do agree with you, Naresh, on this, that we need to have this computer vision integrated with photogrammetry. So
Yes.
We can build on the applications faster, and with the amount of data which is coming, to process that data and to build applications from that, we need uh, inputs from the latest
Otherwise, it won't be
algorithms.
consumed by the
Yes,
masses,
yeah, yeah,
because
yeah.
we do POC, that's done, very good
Yes.
algorithm we have developed. But can we scale it? Can it go to actual, a city like NCR, a Delhi kind of city, like huge Indian cities, and suddenly like, oh,
Yes,
it's a tricky problem to handle now.
yes, yes,
Completely
yes.
agree with you. Cannot agree more than this. Fully agree.
Yeah, and asking, continuing to that, Naresh, I would like to ask you this big data management technology which you were talking about in your presentation. So, apart from the project you mentioned, have you implemented somewhere else as well? Is that live, that kind of technology?
Yeah. So our data management platform is ready actually. So I'm transitioning from Sexmin to a startup where we are building that solution. So data
Okay.
ingestion is already handled, but that's not enough actually, because we have to have data specific algorithms. So then the data can be analyzed. So I think it will take about 3 to 4 months, maybe up to 6 months of time for us before we can safely say that, okay, now you bring in a satellite image and bring your lidar point cloud and we can efficiently manage, or even like, I don't know if it is being done or not, but like a lot of radar imagery is out there. European Space Agency has free data available. ISRO is going to launch a satellite NISAR in collaboration with NASA probably by the end of this year. So a huge flood of data is coming from radar, and a big flood is coming on hyperspectral also. And then there
Yeah.
are optical imageries. Their 8 centimeter resolution is publicly available in the Netherlands, as Dr. Mila said. So, we can process one image, two image, that is fine. But suddenly when you have, in radar interferometry, when we process radar data, our single stack easily goes to 300 images, and each image is about 5 gigabytes. So 1.5 terabyte of data we are looking at. Now you put on top of that some lidar point cloud also for geocoding, and then you add a little bit of hyperspectral imagery on top of that. That would bring, we don't even know what it might bring, what information extraction can
Yes.
come out of using the data. And that's a problem statement that is there now. I hope in a couple of years we will see some very very interesting results. What on one point I would be adding what Dr. Miller was showing, that they are doing this wonderful solar analysis in the Netherlands. There's another very interesting application, because I was also looking at that problem statement, is when people are looking for a new house hunting, a very important parameter personally for me is that my house should have sufficient sunlight. And now to go there, I will probably not understand, will it be there in the summers and winters, what's the situation. But if there is a solution out there, okay, there's a 3D model of the society where you are going to live, and this is going to be the solar radiation and whatever information you can get out of that becomes a very interesting problem for a lot of people who are looking for a new house.
It is. It is. I remember when I bought my first home 6 months ago. I was very much particular about the orientation. The backyard has to be southwest facing
Yes.
for the sun. And it's true. Everybody who comes to my house says, "Oh my God, it's such a well-lit house." I said, I thought about it. I've
Yes.
spent. I mean, it was a conscious decision to buy this lot
Yeah.
because I knew the backyard is southwest facing and there got to be a lot of sunlight. I mean, this is what I had knew intuitively, but yeah, it would be great to have some 3D model tell you, right?
Yeah. Some
Yeah.
data backed decision making can be done. Then you know that, okay, this is what it is. And one more point, for data democracy. So in India, Dr. Mila, what happens is that anything that is more than 1 meter resolution, it has to go through a certain legal process. Nobody can have 8 centimeter resolution data without getting government approvals, and that takes like 3 to 6 months. Now the policy got changed like 3 months ago, and Indian companies can actually acquire data which is better than 1 meter in resolution. So that's a possibility, but right now we don't have such satellite operators coming out of India. So that's where the new startups are coming up. So Pixel is a startup based out of India. They are going to launch some 30 odd hyperspectral imaging satellites. There's a radar constellation also coming up out of India. So high resolution data will slowly become more and more integrated. But on the drone side, what metaverse might end up doing is that they might end up democratizing this data, drone data. And it sounds a little bit strange, but it might come out of gaming industry, because gaming industry is changing. Yeah, because people love games. Gaming industry is huge, and one of the largest gaming companies recently acquired one of the largest photogrammetry companies. because they want to have, okay, wherever you are, fly a drone, create a 3D model, and we want to integrate that into our gaming software. So somebody wants to drive in Netherlands, or suddenly they want to drive. So the realistic model, and that's where it might happen that drones might end up becoming more of a commodity and more democratic data will be available, hopefully soon.
But Sonia, I have a question. Sorry for not knowing the answer, but how are the legal requirements for flying drone in India? You're mentioning you are acquiring such a big data, or for gaming now is coming as a requirement, but I assume that not everybody can just go out and fly a drone.
That policy got changed actually like last 2-3 months ago. And as long as the drone is Indian, so we don't allow Chinese drones to fly. Though 95% of market in India is owned by Chinese drones, only DJI, the ultimate champion around the globe. But as long as you have a certified manufacturer, a certificate that, okay, this is a made in India drone, then anywhere there is no red flag, for example, airstrips and, military zones. So that complete plan is publicly available now, where there are green zones, and in those green zones, once you have a proper license, there's a small certification that is that anybody can fly now. So that happened like 3 months ago. Before that, flying a drone was, 5 layers of permissions you had to get. So government is changing a little bit now, and the data is becoming more and more democratic in India also.
So, and that too for Indian companies, Indian owned companies, Indian companies, they have given a lot of opportunities in terms of acquiring the data when it comes to India now. And this is like 2021 has been a watershed year for India in terms of geospatial availability, because we have been struggling for getting geospatial data at a higher resolution since, say, almost 20 years. I am struggling.
Yeah.
Okay, Naresh, just a quick one.
I have a question for him. Oh, I think he left. Okay, no worries.
Yes,
yeah, Shikha was asking something.
No, Naresh, I had a quick question. You are a founder, you're a CEO of Texman, right? That's
in between. I'm shifting to something else next month.
Okay,
Deep Matrix, where we are building this big data management.
Who are your clients now? Who are your prime clients? Who are your key clients? What, I'm not talking about the names, but just to understand.
Mining is one big industry, because I am a mining engineer, and I know a few things about the mining industry. So mining, I see a big technology gap there. And the second one is any public sector project where the large data is being generated. For example, Swamitwa is there. Other than that, there's the National Rural Roads Development. They are also going to have the scheme that all the rural roads in India will be scanned using drones down the line. So that is where we are looking, not really clear, but mining is our first thing where we think that we will be getting paying clients in the beginning. And after that, we will see. We don't really know. We just know one thing, that in a couple of years, there will be a need of data management. And that is our prime focus, that, okay, when Dr. Mila wants to process, okay, our POC is done and we want to scale it on a larger platform, then we're like, okay, we can compute that for you. And that's why,
analytics is the buzzword nowadays, right? But really still the bigger beast to tackle is data management, even project wise, even revenue wise, the work wise.
So one small example I'll give you, that the Large Hadron Collider at CERN, in 1 second of experiment, they generate 1 petabyte of data in just 1 second. They're sitting at 200 petabytes. They ended up making their own data management platform. And we are also exploring that if we can use that management system for GIS and Earth observation industry. So as Swati ma'am was asking, so we are at that stage that we know, okay, this can be handled by this and this, but maybe something innovative, completely new has to come out of this, because location has to be attached. Then our data is not unstructured, semi-structured kind of data we have. So this will create a very challenging problem, very technically very difficult problem to handle. And there's another, one gap, So when I was at Delft University, Professor Hugo Ledoux, he used to say that to us quite often, that I don't know why they get, all these people in the GIS industry. GIS industry is actually a computer science problem statement. So it's a problem for computing, how you can compute. And so that's what we are doing now. So I have a team of computer scientists who are tackling it from absolutely data perspective. They don't know anything about GIS and remote sensing and drones or anything. They just know that the data is coming and we need to manage that.
So actually, the GIS industry is your user.
Yeah, exactly. So we are the users of the technology. Yes.
Yes. So and then we make, like, when we use this technology in our own sense, we can deliver more valuable insights to our clients. So basically, people, when they talk about geospatial, they understand it as one technology domain. But geospatial is a suite of inter and multidisciplinary technology domains,
Oh, yes, yes, absolutely.
and that is to address the real world problems, because real world is not one discipline; it is conglomeration of multiple disciplines. So yes, there are some problem in geospatial which pertaining to data and all that comes from the computer side, and even in data also there is something which is beyond computers, like the problems with photogrammetry or the problems with, say, radar or all this. It's not a computing problem, so it has its own inherent
Yes.
technological challenges also, for the lidar, to get meaningful data out of lidar, to get meaningful data out of spectral. So spectra, understanding the spectra, understanding the various. So it's a suite of technologies, and we need it to approach it from multiple ways, to bring meaningful data for the end users. That is what I see geospatial as. So there is some problems which would be handled by the computing. There will be some problems which would be handled by the optical people. There will be something which would be handled by the, say, the radar people, the lidar people.
So just to
So
summarize, the two key challenges with the GIS data would be the data quality and the data size of the data.
yes,
Am I
Yeah,
correct?
yeah,
yes.
absolutely, absolutely.
From
Data
computing side,
quality is
yes.
a huge challenge, ma'am.
And data
Very
integration.
big problem. Yeah.
Yeah, and data
This is a
integration.
data
Yeah.
integration. And free availability of data is also one of the things. So European Space Agency had two radar satellites for freely available data for whatever you want to do. But one of the satellites died a couple of months ago. They lost connect, so there's only one now. And the commercial satellites are like extremely expensive. So, but data quality management, data quality is a big issue. Yes, and
Also,
I'm
we
just
don't have to forget it comes to data sharing, there are a lot of privacy issues that we don't have to forget. With all these UAVs, you acquire 2-3 centimeter resolution images and you can see everything. So we are having quite some research on that as well, because
yes,
not
yeah.
every you need to get consent of the people to share all this data publicly. So
Yeah. Well,
don't
Europe is
forget
a little bit
ethics
sorted
and
there.
privacy.
Yeah, Europe has
So
a very, a very good platform.
so
Inspire
we
framework is there.
So
Yeah,
we
ma'am.
have one question from our guest finally, Mr. Sarma. Yes, please open your mic and put your question.
Unmute yourself, Mr. Sharma.
What happened?
Mr. Sharma, you can unmute yourself. Okay, there's a question from Mr. Kumar also, Dr. Kumar. Any one of you can please unmute yourself and ask your question, please.
Yeah, so good afternoon, everyone. So just quite 10 minutes before just your delivery list, speeches from the different, speakers, either from the University of 20 and, Mr. Sony. So actually, I would like to know about as far as our India is concerned. So some, incubation center where the, geospatial people or, inspiring mind or innovators, they are coming together, and some incubation center which is having their uh, some sort of maturity stage, they are going to provide some infrastructure or some seed money like that. So I would like to know something about this.
Okay. So I can give a few inputs on that. So as I said that under NMICPS program, there are 25 technology hubs of innovation. And one dedicated hub for GIS and remote sensing is at IIT Tirupati. So you can approach IIT Tirupati if you have any specific idea and something that you want to build or develop some sort of a technology. They have availability of funds also, and they're mandated to support people like you who are taking initiatives. So that one I know. Other than that, most of the academic institutions, IITs and NITs, they have some sort of GIS program. But like if you talk about drones kind of applications, then IIT Roorkee and the IIT Kanpur are the hubs where all the innovation is happening. Anna University, under Madras Institute of Technology, they have an extremely evolved program on drone development, probably like the most advanced lab in India for drones also. So these are a few places that I know where you can directly approach.
So yeah, so related with the our my earlier questions, is there any some sort of flagship schemes or schemes which has been launched by the government of India, either Earth Science Department, DST, or other ministry like that?
Drone Shakti. For drones, you can Google the term Drone Shakti. It's a PLI scheme, performance linked incentives, and the government of India is putting a lot of fund on top of those. Drone Shakti is connected with Skill India program also. So where government provides a lot of incentives and subsidies and everything. So you can check that specifically for drones. Other than that, if you are working on some sort of satellite imagery, then you have to go to NRSC right now, or some globally freely available data sets, like European Space Agency has a lot of freely available data sets. But government of India specific, maybe Swati ma'am knows a little bit more about this, but I'm not aware of it.
Mr. Sarma, you can unmute yourself and ask the question, whatever you have. I think he's unable to unmute himself.
You can type also, I think.
Yeah.
So one, a small query I have, and I think to Dr. Mita, University of 20. Yeah.
Yeah, please.
Yeah. So
That's Dr. Mila. That's Dr. Mila. You please have the query.
Yeah, but I want to hear the question.
Yes.
Yeah. So definitely. So from the university or institution who did PhD, they are looking for some good research area, domain area, which is based on the cutting edge technology. So kindly some you would like to in this way you can apprise us, so where we can put those student to that level of postdoctoral research at your university, or similar to your university.
I'm not sure whether I exactly got your question, but I can tell you that University of Twente, and more specifically ITC, the Faculty of Earth Observation and Geoinformation, is a very international faculty, and it's pretty much well known in India because we also have a joint research program with India. So there is a very strong collaboration with Indian universities. So one option is that you can send MSc students to ITC to be taught, and the other one is the joint research version where we collaboratively teach students in India. But this is for MSc degree. For PhD degree, usually students are submitting proposals directly in the system. They can submit in the system, and then depending whether the proposals are, for example, approved by promoters, by full professors, they can go forward. But it's always related with financing. They should be allocated to a certain project. They should be linked to a certain project that is financing these students. Also, there is a possibilities for distance, let's say, research, like the supervision of Shubham, who is now not anymore in the audience. He left, but he was in the beginning. So with him, we are doing distance PhD research. He's based in India, in Delhi. I'm pretty happy with this configuration because he's a brilliant person working very hard on a historical overview of Delhi, and I expect from him very good results. He is very knowledgeable. So this is a distance way of PhD. For postdoctoral research, as I mentioned, there should be some kind of a project, and there is usually a vacancy, and there is usually a lot of competition between people from all over the world. Yeah, I don't know if I explicitly answered to your question, but this is how, for example, a collaboration between India and University of Twente can work.
Dr. Miller, you answered it very well as to what would be the opportunities for students in India in Twente. And as you mentioned that there is a collaboration with the Indian Institute of Remote Sensing. So students study at Indian Institute of Remote Sensing, and some part of their work they conduct at ITC Netherlands. That's one program I'm aware of. And they can also join directly to the MSc programs at Twente, and similar collaborations. I don't know other than IIRS if there is any with the other Indian university.
There is a long-term contract between India and University of Twente. This is called Joint Research Program, and there are many students from India that we are jointly supervising and educating. Yeah.
So kindly elaborate the what exactly distance education for the PhD program. So kindly suggest. I am looking for this distance PhD program. So what types of procedures?
So we can share it with you on email. Because this is not the right forum to say. So we'll connect with you to Dr. Mila, and you can correspond with her and take your queries forward. So I think it was really a very engaging session today, understanding the emerging technology space in geospatial. And we had a very intensive discussions also as to how we can take it forward from here. And we got really very good headway in terms of what are the programs in India and outside India, and what are the new areas, new avenues where we should look forward to. So thank you all our presenters for this beautiful session on spatial talks. We look forward.
Thank you very much.
Thanks, Yogita. Thank you.
Thank you to all the speakers. They agreed on such a short notice with us to join on this forum. And in absentia, Mr. Behra as well, because I think he left. So thank you so much. And we will be posting this video also. So it will be shared to all of you.
Thank you.
Okay.
Thanks, Swati.
Thank you.
Okay. Thank you.
Good.
Bye-bye.
Bye-bye. Have a nice day.
You too. Have a nice day.
Bye-bye.